we're going to look at some examples of converting between molecules and moles and mass. These calculations are very similar to the ones we did before. We were converting between atoms and moles and mass. The only difference is now, rather than using the molar mass of just one atom, we're going to use the molar mass of the molecule or the formula unit if we're dealing with ionic compounds. Again, we'll just use Avogadro's number to convert between molecules or formula units and moles, and we'll use the molar mass to convert between moles and the mass. Alright, in the first example, we want to know what is the mass of 2.39 times 10 to the 24th formula units of calcium nitrate. And again, the reason we call this formula units as opposed to molecules is because we're dealing with an ionic compound, not a covalent compound. So the first thing that we need to do is figure out what are our conversion factors. So we're starting in formula units, and we want to go to mass, so it's going to be a two-step conversion. So the first thing we need to do is figure out what is the molar mass. So I just add up. I look at the periodic table and get the molar mass of 1 calcium. I've got 2 nitrogens, so 2 times 14.01, and I've got 6 oxygens, so it's 6 times 16. When I add all those up, I get a molar mass of 164.10 grams per mole. I like to rewrite the molar masses instead of doing grams per mole. I like to write them as conversion factors, right? So 1 mole of calcium nitrate weighs 164.10 grams. And then the other conversion factor that we need is that 1 mole is 6.022 times 10 to the 23rd, whatever we're dealing with, in this case, formula units. So I'll set up my conversion. I've got that many formula units, and I'll have a two-step conversion. So on the bottom down here, if I have formula units in the numerator, I need formula units in the denominator. That means that went in the denominator, so that will go in the numerator. Alright, so I've used that conversion factor now. So now I have moles in the numerator. I need moles in the denominator, so I'll use my other conversion factor. 1 mole, and then its partner goes at top, 164.10 grams. So formula units cancels, moles cancel, and I'll be left with grams. And when I multiply this out, the answer that I get is 651 grams. Alright, in this example, we want to know how many moles there are in 76.2 kilograms of carbon dioxide. So again, this is going to be a two-step conversion because before I can go from mass to moles, I need to go from kilograms to grams. I'm again going to need the molar mass. So if I add those up, the molar mass, I have 1 carbon, I have 2 oxygens, so that gives me a molar mass of 44.01 grams. Or I can rewrite that as 1 mole is 44.01 grams. I also need the conversion between grams and kilograms. So I know that 1 kilogram is 10 to the 3rd grams. So now I'm ready to do my conversion. So I've got 76.2 kilograms. So I need kilograms in the denominator. That means 10 to the 3rd grams will go in the numerator. So I've used that conversion factor. And now I have grams in the numerator, so I need grams in the denominator. So I have 44.01 grams. It's equivalent to 1 mole of carbon dioxide. So kilograms cancel, grams cancel. I'll be left with moles, which is what I'm looking for. And when I multiply this out, I get 1,730 moles. All right, in this last example, I have another kind of twist. So we're given 40 grams of glucose, and we want to know how many hydrogen atoms there are. So we'll do this just like we did the other problems, and we'll convert from grams into moles into molecules of glucose. Once we get to molecules of glucose, we can look at the chemical formula for glucose and realize that for every 1 molecule of glucose, there are 12 hydrogen atoms. So the total set of conversion factors that we need to use are here. So we need the molar mass. I have 6 carbons, 12 hydrogens, 6 oxygens. That gives me a molar mass of 180.18 grams per mole, or I like to rewrite it like this. I have Avogadro's number to get me from moles into molecules. And then once I have the molecules, if we look at the formula, we see 1 molecule of glucose contains 12 hydrogen atoms. So once I have the number of molecules, I can multiply by 12. I'm going to break it up into 2 steps, but you could actually have this just all in one long conversion factor. So first, I'm going to get the molecules of glucose. All right, so grams will cancel, moles will cancel. This will give me molecules of glucose, and I get 1.67 times 10 to the 23rd molecules. All right, now I just have to multiply this by 12. I'm actually going to set it up like a conversion factor. So I have 1.67 times 10 to the 23rd molecules. And I know that 1 molecule contains 12 hydrogen atoms. The molecules cancel. I'll be left with hydrogen atoms. And the result that I get is 2.01 times 10 to the 24th hydrogen atoms.